This is a webinar for the StatPREP project. And the title, which I came up with because I've been doing several presentations on linear regression, I thought I need to make this a little bit more snazzy. So I thought I'm going to show you 3 ways to either invigorate or reinvigorate your teaching of linear regression. Briefly about StatPREP, their goal is very simple and noble. We want to help faculty teach data skills in their introductory stats class. They have a sweet website. Grace, if you can put that in the chat. We are grateful to the National Science Foundation for support for this work. This is Grace, who's behind the icosahedron. I think that's, I wish I knew for sure. Grace Murin she's the MA Programs Coordinator, and we have a link to our presentation. I know sometimes when you do these webinars, you can get overwhelmed with links. So this is being recorded and it'll be available, but if you want to get a copy of the presentation, you can go ahead and get it right there. Cool. I just want to point out some other key people on the leadership team. I already introduced Kate Kozak and Mbika Silva, and then someone who's not here, but who I worked closely with and has really shaped my thinking, particularly about this topic, is Danny Kaplan. You know, I consider myself an expert, but working with Danny and his knowledge of data science and how regression is used in the wild has kind of knocked me down and humbled me a lot. So a lot of what I share with you today came from inspiration from working with him. Here's our overview for where we're at today. We're going to do just brief introductions, and we're going to talk about 3 strategies. These are not the only strategies, and of course, you're going to have a chance to share any ideas that you might have. But I'm going to ask you to focus on the response variable. Think about increasing students' capacity to assess a linear model. And then we're going to end with some forward-thinking ideas that I've really learned from the StatPREP team. And again, down at the bottom, I want to acknowledge that a lot of the materials and the apps that we're going to show you were supported by the National Science Foundation, but the author of them was Danny Kaplan at Macalester College. Briefly, I know we're probably all familiar with Zoom. Why don't you go ahead and practice your ability to engage in the chat? You're welcome to say anything at any time when we'll be following that. I got 2 screens so I can look over and see it. But if you would, maybe think about putting your name and your college. And I'm always interested in who is the typical student you're teaching, maybe the average student. So you're encouraged to use the chat. Don't be shy. It can make it more lively. Also, emojis are encouraged, and there's the basic ones. But there's a whole bunch more. You can always raise your hand if you'd like. We are going to do just a brief breakout room. I have it set up. I want to be kind of flexible depending on the needs of the audience. And if you are in a breakout room, you're going to get a 60-second warning, and then you will automatically be brought back into the main room. So that's basically the deal on Zoom. So let's talk about introductions. Again, I'm seeing some people. Oh, good. Grace is confirming that it is icosahedron. And we've got Catherine from Bennington College. Go ahead and type in your name, your institution, and the average student that you teach. I'm going to go ahead and just tell you a little bit about me. I teach at a college called Highline College. It's technically now a 4-year public, but it was a community college. It is really, its identity is a community college, and I've been here for a long time, since the 90s. It was like my first job out of graduate school, although this is really a second career for me. I teach most of the statistics I learned during my graduate work at University of Michigan in the Center for Higher and Post-Secondary Education. So my doctorate is in higher education, and I just learned how to do multiple regression from a social scientist perspective, using technology, interpreting coefficients, diagnosing models. And then I got kind of lucky because when I came back into the community college environment, stats at that time had become the big enrollment class. And now nationally, it's one of our biggest enrolled math classes of any. So I got lucky because I was interested in it. But I also ran into all sorts of challenges with thinking about, what am I trying to do here? You know, run a line through some points. Like, how sophisticated can I get with linear algebra? So, or linear algebra, excuse me, linear regression. So personally, I've been a little bit dissatisfied with the outcomes we're expecting. So I was really excited to be part of StatPREP, and it really improved my teaching, and that's what I hope to share with you now. Sweet. Hey, let's do a quick pair just to kind of get you to at least meet someone else in the session. Let's see, let me escape and look at how many participants we have. I'm going to stop share. Again, welcome everybody. And we've got 20 of us. Some of us are the leaders. So I'm going to just do it randomly. Here you go. You're going to meet someone. You're going to meet someone. And so just take a second to share who you are, maybe a little bit about why you decided to attend today. And it's just going to be groups of 2 because that's going to give you, make sure that you can go back and forth. And you're going to get a 60-second, we're just going to go for 3 minutes, but you're going to get a 60-second notice. And if you haven't switched sharing, please do once you get the 60-second mark. So you could share who's your typical student. You could also, I was thinking, you know, what's like, do you have a favorite correlation that you do in your courses? Maybe share that. So here we go. This is random. Enjoy. Let's see what happened. We got Ambika in with, okay, so I'm going to move Catherine to 10. So Ambika, you don't need, oh, Ambika went into her thing. Ah, interesting. It's all right. Okay, Kozak. Guillermo, I'm going to move to 10, to room 5, 10. There we go. Hi, Emily. How are you?
I'm fine. I went to a breakout room, but nobody was there.
Okay. Do you want to just sit here with me?
Sure, that's fine.
Tell me about yourself, Emily.
I'm at the University of the South in Sewanee, Tennessee. I've taught statistics, intro statistics, and linear regression modeling for years, I guess, and thought I would just pop in and see what all you're doing, just out of curiosity more than anything else.
Good. Now, and then who's your typical student?
We're a private liberal arts college, so ours are typically standard college age, and it's pretty, I guess, semi-rarefied, I guess, is what I would say. These students are not particularly diverse. They're not particularly, anyway, they're just kind of your standard liberal arts private
Interesting
college. So yeah, it's probably not your run-of-the-mill kind of crowd.
Yeah, a little bit different than what I teach.
Yeah, and I missed your introduction. I'm sorry, I missed that.
That's all right. I teach at a community college that is now technically a 4-year because we have bachelor's of applied science programs, but our students are really community college students.
Yeah.
I teach intro stats. My typical student is a health science major, coming from some kind of intermediate algebra background.
Yeah. No, we you know, all ours are pretty much ready for calculus when they come in the door. So yeah, it's a little different. And where is your community college, Helen?
We are in Seattle, Washington.
Oh yeah.
Yeah, where we have a big community college system. Big community college system. And right now, with COVID, it's just such a challenge.
Everything's a challenge right now.
Everything is a challenge. Hey, welcome back. We have about 40 seconds till the breakout rooms close, and I am checking out who's in. I appreciate you sharing. Interesting. Good. Yeah, we've got about 30 seconds until the breakout rooms. My goal there was just to give you a familiar face. You all have access to the chat throughout the presentation, so you're welcome to do direct messages to each other. If you see someone in the chat window that you know. Good, good. 10 more seconds till they start the full presentation. Oh, there we go. Welcome back. I hope that was good for you, just meeting someone, having, a bit of a connection during this difficult time of disconnection. You have access to the chat throughout. We tried to open this up so you can private message people, or again, put your comments in your chat. I enjoyed reading about you. Hey, the first section, thank you. Yeah, emojis are cool. The first section, I have us to go to the top of the hour on strategy number 1. So without hesitation, let's go. And I'm really curious about whether this is, in fact, something new to you. Here it is. Reinvigoration or invigoration, strategy number 1. Focus on the response variable with the guiding question, what predicts this? Now, let me say a bit about this. So we're going to do an initial exploration where I'm going to show you our apps that have been developed for this project. And we know there are many, many different products out there to use to show data and to use for demonstrations and for classroom purposes. So we are going to go into our apps, but not too much in depth. The purpose of this session is to give you some ideas to reinvigorate that I've learned from StatPREP and I want to share with you. So I'm going to do this example with body mass index. Now, what I used to say is apparently what a lot of us say as mathematics faculty, this is documented, is there a correlation between weight and body mass index? Or like a lot of times we say things like, is there an association between the bivariate data? But now I've completely changed how I approach this to students. I find the response variable of interest, which is BMI. Body mass index. I define it and I'm like, what predicts body mass index? Do you think someone's weight predicts it? Do you think their height, their sleep hours, their blood pressure predicts it? And why is this important? It's a much more authentic way to approach regression in terms of how regression is used in the wild, rather than just asking, is there a correlation between these variables? You can explore now because you're looking at what predicts this. If you can show, for example, that sleep hours predicts body mass index, you can control sleep hours. So you could actually design an intervention. So notice I'm talking more about causality. I've become much more comfortable with talking about causation versus just telling students correlation is never causation or doesn't mean causation. So this is at the bottom of the screen is a phrase from Danny Kaplan is, if you can find a correlation between, an explanatory and a response variable, it allows you to engage with your students to talk about what real world phenomenon would account for that relationship. So some of you, I'm sure, already do this, but this is a real shift in focus for many of us, especially if you're more of the mathematician side of the house. So before we go to the apps, I want to talk about this issue of body mass index. So consider this reinvigoration strategy 1.5. Now, I used to not be a fan of body mass index as an initial exploration with students. Why? Because obesity is a big problem in the United States. And, sometimes I just don't want to bring up stuff to students about overweight. I mean, I look at my students, I look at our culture. So, okay. And plus some of the correlations are obvious, like BMI is correlated with, someone's weight predicts body mass index. So it seems kind of obvious. However, one thing that's happened with BMI is I've decided it's a really good introductory exploration. It's a controversial measure, but it has withstood the test of time. So if you're not aware of the drama around BMI, check out this link. We'll put it in the chat, but really the important one is this one. I only recently became aware of, and please, Grace, if you could put this in the chat, this podcast could absolutely change your life. BMI was developed in the 1800s by a Belgian astronomer turned social scientist named Adolf Quetelet. Some people may say Quetelet. It kind of depends what part of Belgium you're from. But anyhow, this guy's history is fascinating. He developed the idea of using an average, which was generally used in astronomy to account for errors in measurement, to bring it over to the social science world. And he developed small, medium, large sizing. And sadly, he also developed the idea of an average man, l'homme moyen, which then led to inspire Galton, Pearson, and Fisher. And I don't know if y'all are aware of this drama in the field, but if you're going to teach history and teach regression, you're going to have to talk about regression to the mean. And there's not just evidence, there's documents showing that Galton, Pearson, and Fisher were definitely in the eugenics program. It's eugenics in terms of breeding the best, hereditary genetic health. They were the founding. So there's a whole lot of drama around BMI. So I actually really now like this topic. So I offer these for you that you might, and especially that 99% invisible. So we're going to now look at BMI and we're going to go to the little apps. Here's how we're going to do it. Again, I have just 10 more minutes on this first section. The goal isn't to give you a complete treatment of the apps, but if you could, I'm going to go ahead and open it up. And I'm assuming, Grace, I've lost a little bit of track of the chat. Yes, good. I'm going to go back to my thing. I want to just show you that inside the slide deck, I wrote some instructions. So if you want to come back to this, but basically, let me just pour through them. The overview, you're going to go into the app and select the one with regression model, either by clicking here or down at the bottom, there's a picture. I also think this is important because it shows you that there's a lot of different apps in this package, and they all have the same controls. So what you first do when you get into an app, they all look like this. This is the one for regression, is you have to, on the pink, you have to select what data you want to look at and what notice response comes first, because they're trying to highlight this idea of focus on what are you interested in exploring, body mass index, what might explain it. These first two on the left that I have circled in red, that's how you do your sampling. You can set your sample size and you can resample with the dice. I'll go into that in a moment. If you want to see after you pulled your sample, if you want to actually make the graph bigger, you can click this button and you get a big graph. You can do this cool thing, which I'll talk about, showing the auxiliary graph, which shows a visualization of R, the correlation coefficient. You can also, this is pretty advanced, but I didn't know the audience, you can select a covariate. So you can look at your phenomenon disaggregated by, in this case, sex. You can click over here on the stat button and get your model summary, which is your intercept. This is your slope. Here's your explanatory variable, your R squared, and your F statistic. And you can also change your source packet. So let's explore the app. Good. I have 5 to 10 minutes for this. And what I'd like you to do is you have a choice. I'm going to go ahead and open up the breakout rooms if you want some privacy, but you can also just stick here and play around. So this is really the only section of the presentation where we're going to go deep into the apps and goof around and play. So we're going to look at the question of what predicts body mass index. That's going to be your response variable. And we can look at height, weight, income level, pulse, sleep hours. All right. As promised, just in case you want some private time, I'm going to go ahead and open the breakout rooms. This is really just exploratory time. If you don't want to go into the breakout rooms, that's fine. I'm going to walk through these. And since Kate and Ambika are both here, if either of you want to highlight something that I haven't, please do. So when you get into the little app, you always get this main page, which basically shows you what the controls do. I click through that, and there are definitely different source packets. I'm just going to focus on this, but they have brought in problem sets from the different main textbooks. So we're looking at the NHANES 2, which is a National Health and Nutrition Experience Survey. This is a national data set, and I'm going to pick the response variable to be BMI. Now, what's kind of cool is you can actually go into the code book at any time. And of course, BMI isn't very explicit. It just says BMI, but some of them are important. For example, it shows you how the measurement is, what the units of measure is on the height and weight in here. And that's actually really different, is to have quick access to a code book and pay more attention to the variables. If you'd like to ask a question at any time, please just go ahead and unmute. So I'm going to start with height. Does height predict? Okay, so right now, and this is already cool. Right here is the sample. I've got it set to a sample size of 50. You can, and this is a pedagogical choice you have to play with. You know, if you want to set it down to 10, it's going to be smaller, but that might be better if you're doing a classroom activity. Generally, in the demos that we've done, we pick 50. 100 starts to get a little bit crowded, but that's how you can pick your sample size. And then by rolling the dice, you can get repeated samples. So already, this is where you can do exploratory activities where the students are like saying, seems like it's pretty stable and that there's a positive upward trend. That doesn't happen for all variables. I'm going to move over to looking at weight. Again, this is an exploratory activity for the beginning. You want to make your points to show students about positive, negative correlations. So of course, weight is more tightly correlated. Just change your sample size. You can pull different samples. If you want a bigger graph, that's here. And that will show up. These are downloadable. So I've used these often, even in classes where my students don't have computers. I can use this as a tool to create problem sets, to use for exam problems. If I go back to data, I often take this and cut and paste it because I use other products besides these apps. So it's really nice source of data. So here's my graph. Here's the cool thing, this ox plot. The this I bar represents a representation of the variation in the model values. Actually, the standard deviation. This is the mean of the model values and 2 standard deviations. And the one on the right is the raw data, the mean and 2 standard deviations. And if you look at the ratio of those two, if those 2 bars are about the same size, you're going to have a strong correlation. If you pick a variable where there's not a strong, you're going to see the first bar be very small. So this is pretty cool. That's like definitely a Danny Kaplan type visualization of R. If you'd like to look to find the model values, they're here under stats. You can do some interesting things with comparing and freezing, but I'll let you kind of play with that. So I'm going to stop sharing and just give you a few minutes. Again, I want at the top of the hour to switch to the next topic, but go ahead and play and ask questions. See if anyone went into the breakout rooms. Looks like you all stayed here. So feel free to unmute. I see Kate is offering, you can freeze a graph and then compare that to another.
What did you click to get the stats?
Excellent. Let me screen share again. It's under stats here. So here's your data where you can resample. And this is really powerful in bringing about sample variability. This has really changed my life. I'm very unsatisfied now when I see a single example of a scatter plot in a textbook. I always wonder like, what would that look like under resampling? And then the graph is to make it bigger, show the ox plot so you can get your cool visualization of R, and then your stats is over here. Is that helpful?
Yes, thank you.
What else? What other questions do you have?
Helen, I have to leave, but if you, I would highly suggest that you also show them how to do the freezing so you can compare to. It's very useful.
Okay. Once you freeze though, you can't unfreeze.
That's true.
Other questions that you have? And welcome, Chris. We use R with our students. For those who use these apps, are using them in place of R or some other stats package? No, they're using in conjunction with R. In fact, the first year of this project, which was now pre-COVID, so I want to say like 2018, every time we did a workshop, there was an R component. And we have webinars on using R in these apps that can be found on the StatPREP. Ambika, I don't know if you want to post maybe one of those into the chat window. So Lee, they're used in conjunction. And in fact, Kate, I believe Kate has an R supported open textbook. Elizabeth is saying, I had one with a pretty extreme outlier and click. Yes, you often see outliers in these. So I'm a big fan of live learning. Like I know my stuff well enough to kind of know what I want to accomplish with students, and then new stuff happens and we take it. So this brings up a whole bunch of live learning. Outliers pop up. Some of the relationships between variables are very uneven. They don't always go up, don't always go down, which creates all sorts of dynamics when you're teaching. I see another message here. We want to encourage, oh, good. So Ambika is saying we want to encourage this in conjunction with whatever statistical software folks are using. Yeah, I'm not going to name the products I use, but I use a lot of different ones, and there's a bunch of new ones that are coming out. So again, our project goal is to make your class data centric. Other comments about the apps or questions?
I think I have a question.
Hi, Guillermo. Yeah.
Yes, it seems that there are two data sets loaded here. The question is, can we load our own one?
You can if you email the StatPREP team.
Oh, so only they can configure it, let's say.
Well, it's not an easy thing. And let's see, are you seeing my screen now, Guillermo?
Yes.
Okay, so what he's saying is these are two really good ones, NHANES and the natality. There's some really cool stuff in the natality. If you go to the code book, this is medical information on each birth in the United States. Students really like this one. There's really, and there's like a really obvious one is mother's age and father's age. Can you predict the mother's age based on the father's age? That kind of stuff. So then we, but yeah, if you want to upload, then you contact one of us and we work with you. The idea was, again, this is always an evolving website. And the idea was that this would be an auto thing, but it's become a little bit more complicated than that. But here's all the problem sets from the basic stuff. How about other questions? That was a good one. All right, and Ambika put a link to the R tutorials. All right, so that first point, and I'm kind of curious, how many of you are doing the, oh, is there a correlation between versus asking the question is, what predicts this response variable? That has really reinvigorated my teaching. So here's the second. Reinvigoration strategy 2 is to enhance students' capacity to assess the suitability of a linear model. And I'm hopeful that in talking about this, some of you would unmute and share your ideas about this. So what do I mean? As I mentioned at the outset, it's not enough to take us, I mean, let me just back up and say, often linear regression is considered like an easy part of a stats class. Oh, let's take a little break and do something you're familiar with because you've seen y equals mx plus b or linear relationships. And I just wasn't satisfied with the our expectations, not just at my college, but in Washington State. Well, what we're really doing here. So what I would like is to build my students' capacity to assess the model strength. And here's a new idea that came from Danny, using the slope as an effect size. And what I mean by that, and some of you probably know, but like, you know, how big does like there might be a positive relationship and it could be a strong relationship, but the slope could be effectively 0. Now you'd figure that out if you were doing hypothesis testing, but actually in my state, that's not a requirement. But the slope is an effect side. Like if the independent variable or the explanatory variable has an incremental change, what's the effect on the response variable? Is it large or is it small? So using slope as an effect size in the same way that, like, if you've done significance testing with two groups, you often get statistical significance because of sample size. And so the field is asking us to bring in a second measure of an effect size, which is usually in terms of standard deviations. Okay, I'll stop there. But this, I never really thought about. I'm always trying to get the students to interpret the slope, but has anyone else have a similar experience where students don't transfer in their stuff from algebra around how to interpret the slope with units of measure? So I've been really working on this. If you want to go farther in this, of course, I look at heteroscedasticity, I look for the trends, but we actually don't do residual plots. Oops, that says pilots, it should say plots. We don't do residual plots. It's not a requirement for within our course outcomes. So I want to show you an example of what I mean by this. And I'd be interested in, if you want to, because I have 15 minutes set for this section, if you have projects that you're particularly proud of. So first, let me just remind you that the visualization of R in the apps is here, where you compare these bars over the side. That's kind of really neat. And also you can get the model summary here with the R squared and the slope here, where the explanatory variable is given. So here's something that I think I started to do this about 2 years ago. And let me put this in the chat in case you want to look at it. Oh, Lee, we're coming back to you. Thank you. I was told before the webinar to not go there right now, but let's check it out. Okay, so this is an exploration in an intro stats class. The question is, and notice, what matters more to increasing a country's income? Women's education or men's education? There's some details behind here. The data from this problem came from Gapminder World. And if you want to know more about this, I've written a chapter in an upcoming thing about linear regression, and I kind of talk about this example. Okay, so I get all these countries and their GDP, and I have to explain GDP, and I'm like, well, what matters more to increasing that? What better predicts a country's GDP, women's education or men's education? I give them a big data file with all of these, and there's details about, it's the average years of schooling for women age 25 and older. They compute the regression, they fill in all this information. So I'm guiding them. R squared, this was done on an exam. I did a group exam. I'm experimenting with that because Alan Rossman told me, if you know Alan Rossman, he told me he does group exams. I'm like, if Alan Rossman can do group exams, then so can I. So they do the regression for women's education, then they go and do it for men's education, and then they jump to the end. Based on your analysis, answer the original question: what matters more, educating men or educating women? Okay. This final question, if you know Bloom's taxonomy, is way up there because it's synthesis and evaluation, but this is what I'm talking about. I have reinvigorated my teaching by having higher expectations around doing this kind of analysis. Am I successful? Well, kind of. But here's the deal. If you look at the results here, they're about the same. It matters. Educate everybody. That's the answer. And students get a little nitpicky because the slope of, I think the slope of women's is slightly higher than men. Can't quite remember right now. So they get hung up on that. The slope is a little bit bigger, but both the slopes are really good. The R squareds are the same. So anyhow, this is an example of what I mean. There's some open-ended exploratory activities that I wanted to show you that can build this. These resources are on our webpage. This one I wanted to show you. This is an example of an exploratory activity. Find 3 explanatory variables that are predictive of systolic blood pressure. Here is, I also want to show you because here's Danny's, here is Danny's explanation of those cool bars in the ox plot that show R. But in the end, and this is cool, like if you want education, read that. And here's what he has, an exploratory, the variable name, the fraction of the variable explained by that explanatory, and the change in response per unit change in the explanatory. So I have reinvigorated my teaching by doing more of these type of activities. There's another one I wanted to show you that is also exploring relationship patterns in numbers and words. And this one is really basic. This is something that I've been doing for a long time, where I give them a template. Again, it's just astounding to me after all those years of y equals mx plus b, interpreting m just doesn't seem to transfer. I don't think I'm the only one that's having that challenge. So this is a really basic exploratory activity. Again, I'm using systolic blood pressure. Find some explanatory variables that slopes up, find some that slope down, and then try to interpret the slope of the line through this template. These are attempts to build that. But ultimately, I want them to put all the measures together. Again, I don't want to overload you too much. Now, at this point, I had till quarter past the hour on this topic. I thought this would be a natural spot for people to unmute and share their thoughts so far. So my next slide for this section is like, hey, what do you have to say about this? Including additional ideas about reinvigorating your teaching of linear regression. Our last section is upcoming, which is some big ideas from StatPREP. So who'd like to unmute and share something?
I'll risk it and go. This is Lee.
I know it's scary. Thank you, Lee.
So I guess I really need to delve into these and just kind of like look at them myself and make sure I'm comfortable, because I know for anything new technology wise, I want to play around with it and make sure I understand what's going on so I can anticipate the common errors students will make, you know,
Good
with
point.
it. So
I'm assuming you're using some data-centric tools already?
yes. Yeah.
Okay.
So we're doing some stuff with R, and they have some data that they have to work with relative to that. So it would be a matter of like, how do I want to incorporate whatever's here with what I already do? Because they end up doing a big project at the end, you know, with some data analysis where they're, I mean, of course, their data sets have many, many more variables than they're going to analyze. So they have to decide which variables do we want to work with, and what questions are we going to try to answer by looking at our data. So it's
So
a
they
matter
develop some, and again, the project, the StatPREP, these tools have been useful to people. We get good feedback on them. StatPREP is about making data-centric stats class. We're often preaching to the choir when we have webinars because we attract people that are already of that ilk. But we are in kind of a challenging time because stats is the biggest enrollment class. And in many classes, the use of real data and asking questions of data and having students explore is not happening. So that's our goal, whether you decide to use the apps or not. So in your projects, students would develop a research question?
I mean, I give them data that they can use, so they don't have to go look for data and clean data. Like here's, you know, 100 different data sets you can choose from that are already, you know, I've already kind of vetted them so that I know that they can work with them. And then they have to decide what questions they might want to investigate related to that data. What question, you know, whether it's comparing to quantitative variables and comparing them relative to some categorical variable, or they always have to do some kind of regression with it as well. So there's a bunch of questions that they have to try to explore, and then they write that up. So,
Okay.
and it's a process. It's not something that they, you know, we have stages to that to get them through the whole project.
Excellent. Thank you for sharing that. Who else would like to share something or make a comment or ask a question about what we've done so far, including disagreeing with anything I've said? That's fine. Elizabeth, thank you.
Yeah, so one thing that I've done, and I feel like I could probably tweak it just with these two things that you've said already, but I give them like a description of two things that might be related. So of course, height and weight's in there, but also like the number of MP3 players sold in Ohio compared to the number of skateboards sold in Florida. And you know, why might those be related, or how related are they? And so at first I just give them a description, and they have to put those from -1 to 1 of how related they think they would be.
Mm.
And then I give them a graph. And so of course, you know, you can't always tell, and these are all very small data sets. So that's another thing. It's like no more than 20 points. So that's kind of hard. But then can you say, okay, now that I see the picture, am I able to say, well, you know, I thought that this was actually a positive relationship, but the graph looks more like a negative relationship. And then I give them the data, and they can actually calculate. So, but they have to think about it before they calculate that R value, so that they're at least, hopefully, crossing my fingers, hopefully they're thinking about like what it actually means. Why are we looking at these two things? But I really think I can kind of ramp up that understanding just by changing some of the language with how I asked them to do those first parts.
Yeah, and for me, again, there's a lot of research about how mathematicians tend to approach it, which is like, oh, is there a bivariate relationship versus that idea of, hey, what predicts this thing, which is a major use of regression. There's an outcome we're interested, and we want to know what predicts it so we can design an intervention. That would be in a causal place. Another idea that I've learned from Danny is sometimes this variable, the response variable, is hard to measure. So you find something that's correlated with it, that's measurable, and you use that kind of as a proxy. It's blown me away, some of the things that I've learned from this project. I think we got time for one more. Does anyone else want to unmute and share something that they're doing in their classes? Or ask a question? All right. So I showed you in one of those links, this is worth thinking about, this visualization of R. I want to say, R doesn't generalize. The Pearson's correlation coefficient doesn't generalize. So a lot of the leadership in StatPREP is like, skip R. And I'm like, we can't just skip R, because at every community college, it's like, that's one of the easiest things. What's your R? 0 to 0.3, 0.3. Okay, but R does not generalize to multivariable, which is really the bottom line with regression. Single variable linear regression is, with a single explanatory variable, is not really used out in the wild. Everything is a multiple variable. So if you're moving towards like a data science program, you might want to kind of explore that and think about the utility of R versus R squared. Also, I want to point out that there's a really cool thing within our materials, and if you're interested, I'm just going to say it. Danny has come up with a general approach to hypothesis testing that cuts across all using the F statistic. It's kind of cool, so I'll throw that out. All right, so reinvigorate strategy 3. I've got about 10 more minutes of sharing some ideas, and then we'll just have the last 5 minutes for open questions. So these are some forward-thinking ideas that I've learned from StatPREP. So first, their message is simple. Introstat should be data-centric. Students should learn to explore and ask questions of data. And I've given some ideas so far about shifting the question, focusing on the response, better job at analyzing the model, which is evaluative and synthesis, and engaging in more exploratory activities. Of course, I need to put in a plug for a workshop that's being held in Fort Myers, Florida on May 20. It's May, actually, that's interesting. It's May 20th through 22nd in 2022. Whoa, it's not a palindrome, but it's something. So I don't know, Grace, if you can put the link in case any of you are interested in coming to beautiful Fort Myers. The team will be there, and that could be fun. So here is, boom, here's some forward-thinking ideas. I picked out 3. So engaging students in identifying which is the response and which should be the explanatory. Apparently, we don't do that very much in an intro stats. And Danny has developed an activity. I think it might have my name on it. No, it has his name. You'll see some of these, the author, they're either me or they're Danny. They're really a little bit of both. But this one is a really good thing to check out. Because if you're not so familiar with how regression is used in the wild, this will help you orient yourself. So within a lot of the class activities, you're going to get an education. Okay. But the bottom line is, he's got some rules of thumb to work with students. Call it your response variable if it's what you're trying to predict. If the variable is being caused, and this really floors, I mean, because I know that so much, you know, it's like we have that mantra, correlation is not causation. And then we show all these spurious correlations. But the point is, a lot of times you're doing regression because you do think there's a cause and effect. You can't prove it, but you're exploring it for the moment. And maybe actually the theory backs it up that there is a cause and effect relationship. Okay, so call it the response variable if it's a variable that's being caused. Or that might reinvigorate your teaching to actually deal with that more, or if it's the outcome you're interested in. So anyways, this is kind of interesting to think about bringing more of that into your teaching. I also, this one's very controversial to me, because I teach at a really as a community college. Students are coming from algebra, but they're like, don't use y equals mx plus b except as a reminder of what a slope is. Read the slope off a graph or a regression report. I'd be really interested in, does anyone already do that? Kate Kozak is encouraging me, like, skip this. Okay, skip the y2 minus y1 x2 minus, I teach co-requisite stats. So I kind of have to cover algebra topics in support. And when you think about the algebraic approach and graphical to teaching linear growth, and then you get into regression, wow, it's a real interesting space. So read the slope off a graph. So you've got these excellent apps. You can zoom up the graph. Let me just show you what one of those would look like. So if you were looking at body mass index and looking at weight, you could then look at the big graph and you could estimate these things. You could print this off and use rulers to say, okay, 50 to 20 and pick another 100 to, 30 something. So this is what Kate's doing with this, is staying away from the formulaic approach to slope. I thought that was pretty earth-shattering for me. And then, as I mentioned before, interpreting the slope as an effect size of x on y with the guiding question, if the input changes, how much does the output change? So don't use y equals mx plus b, except as a reminder of what slope is. And there is, I think I already showed you this one. There's some activities around that. And then I have one more. Well, I put in here in this slide, what's the purpose of regression, which I think we've already kind of addressed. But there's some definite material to think about of how it's used out in the wild. Here's the last one. And this one, I'm still like, whoa, what am I going to do with this? So Danny says, all right, sometimes regression is presented as a way to predict a value of y for a given value of x. I'm pretty sure most of us have done it. Predict, the output for a level of the input variable. Or a traditional way is, if x equals this, what is y? But usually I'm pretty good at using the word predict. Look what he says. This is a seriously misleading and not a proper statistical prediction. Wow. So if you read the fine print, it makes total sense, because the actual data that for a given input value, for a given value of x, the output has some kind of a range, which we assume to be normal, centered at the point on the regression line, but there's a standard deviation. So a true prediction made in like the data science world isn't a single value. It's a range of values based on a probability that brings in the standard deviation. Wow. I still haven't done much with this one, except to think about it. So that's my third reinvigoration strategy, the different ideas. One was don't bring in y equals mx plus b. Then there's this one, think more deeply about your prediction. And then there was that first one about spend more time with the explanatory and the response variable. So in terms of summary, these are my suggested ways to revitalize, reinvigorate your teaching of linear regression. We are grateful to the National Science Foundation and I'm personally to Danny Kaplan for teaching me so much about this topic. So with that, we're going to take our last few minutes and just open it up for Q&A. So comments or questions? I know someone's got a comment. Doesn't have to be, you know, anything too profound, but just something that's striking you about what I presented that can help us, you know, with future webinars, working with other participants. What do you think? Jonathan, you look like you're dying to say something. You just need to unmute. There you go.
Well, I don't really know much about statistics, but I was reading a statistics book this morning, and it framed the entire purpose of regression as you're using it to predict the value of something. So it's really different from the standard textbook approach, I guess.
Yeah, that's because this project has been informed by data scientists in the field. Because, you know, our intro stats should be kind of more aligning with that field. So thank you for saying that. That was validating to me. How about Guillermo? Guillermo, what do you think?
Good question. I am a little confused because I think I would need more articulation about some of the ideas that you have just given. For example, I didn't understand very well what you meant to say when you said don't use y equals mx plus b. So how else could the regression line be expressed with an equation? Or what do you mean exactly with not using that?
That is a great question. Does anyone want to tackle that before? Because I definitely could have to say something, but would anyone like to say their impression of that?
I kind of took it as instead of you don't want an equation. You're only looking at the slope that you would have gotten from like your report, whether it's on a TI-84 calculator or some other process to get the values, and it's just going to tell you what that slope is, and then you're not going to put it into an equation. You're going to think about what that slope is and how it changes. So that's kind of how I took that.
Oh,
Yeah,
I see. So it's let's say working with the slope just as we work with the correlation coefficient with some other coefficients as a measure of something particular. I understood that perfectly as a measure of size effect, and then essentially the questions would be only about the slope. So you are suggesting that we don't ask students to get the equation of the regression line, nor to use it to extrapolate or to interpolate.
Usually, the intercept of the regression line doesn't have meaning. Not always, but most of the time, because it's some 0 point and it's extrapolation, right? Usually what's important is assessing the suitability of the model through the R squared, through using slope as an effect size. And then I gave you that final slide about even the way that we do prediction, which is make y equals mx plus b and plug in a number, that is inauthentic to true regression modeling in the field. And I don't have an answer for that, Guillermo, I think most of us are probably going to go ahead and make the regression equation because we do it and we're mathematicians. But again, my head is always spinning when I'm involved with this project, and I'm interested in moving more into understanding how is this stuff used in the wild. So I just offer that.
So when you say that the prediction is not a proper prediction, I guess you mean because it's more common that those predictions are complemented with what is called interval predictions, right? So every point is turned into an interval or is tied to an interval. Any prediction point is
Yeah, my
tied.
prediction should be a range.
Mhm. Yes,
I don't
yes,
do
yes.
that in my classes. I can't yet. I haven't found a way to like bring that in. So MX plus B will come up. But you know what's weird? I don't know if I use another product, and the way it spits out the regression is it says output variable, and it gives the name equals intercept plus, and it gives the slope times the explanatory variable. Like it writes it out in words.
Mhm.
Students wouldn't really see it as MX plus B. It actually gives B plus MX. I mean, I'm still exploring with this fact that students don't transfer much of their knowledge of linear functions over to this space. And maybe I'm alone. I don't think I am. And it seems like when you bring in MX plus B, like there's a lot of projection of stuff that's not so helpful to the moment of what you're trying to teach.
Yes, well, I guess it could be a very good complement because actually the course outline of record that I am using, well, the way it is written down at Cuesta, one of the student learning outcomes is having students being able to do punctual, they call it point and interval estimates. And well, the concept of point and interval estimates, mostly we work it with confidence intervals because, well, you pick a sample and the mean in the sample is a first estimate of the mean in the population, but we have to build the interval around the sample to have more of an interval estimate. Interestingly, we don't do the same for the estimations, for the point estimations that we get with a regression line. So in that sense, it's kind of interesting that
Isn't
we
that
do
interesting? Yeah.
Yeah, it is that we do the point estimate. It's very common to do it with a regression line. However, we don't teach how to turn that point into an interval estimate.
And truthfully, Guillermo, I think if your examples are only with like 10 data points where there's not like a range of values for a given value of the explanatory variable, if your data set's so small, I don't think you really can do that.
Well, it doesn't have to be that small. It could be some hundred, or it could be a larger sample size. But well, perhaps what you are saying, I think what I find most relatable is the interesting thing that certainly we don't cover interval estimates or interval predictions together with linear regression, while we do kind of the equivalent when we work with confidence intervals.
Which is an interval for a population parameter.
Mm-hmm.
Very interesting.
Yes, yes.
Okay, I'm glad to see you're making some connections there. I had someone ask for a link to the slides. Again, I'll post that in a moment. I want to respect people's time, but I'm not going to, I'm going to leave when people are done with their questions, but please don't feel bad if you need to leave now. I want to say thank you for being here. And I hope that something that we've shared from this project has sparked something in you and given you some ideas. So have a great